Okay, so we're going to do some more with differential equations, and hopefully a lot of this will sound similar because you've been doing that. We've done it before. And so again, a differential equation is when you are given the derivative of something, and it describes the relationship between the rate of change and other particular values. Sometimes x, sometimes y, sometimes both. So it doesn't it could be or neither. It could be constant. It could be dy dx equals 5, as we talked about yesterday. So these are all called separable differential equations. There are examples of non-separable ones. An example would be like dy dx equals y minus x plus 1. In other words, if I try to get all the things with y on one side and all the things with x's on the other, I wouldn't be able to do that. So that's what non-separable means. Our class is limited to separable differential equations. So remember when it asks you to find the particular solution, because it doesn't have to be x and y. It means that if they give you this, the answer is an equation for this top variable in terms of the bottom one. Okay? So it's an equation, so I have to, my answer is going to be y equals and then something with x's in there. And these are what we're familiar with. So I tell you that because sometimes if they're not x and y, it's hard to know what you're solving for. So remember what our steps are. The first step is to separate the variables. So you're going to use some algebra. I want to pop this y to the other side. So it'd be y dy is equal to negative x dx. And you may say, well, how did you know to do the negative with the x? I could do it both ways. So I just did it that way. And then what's your next step? Your next step is to integrate. I would get y, 1/2 y squared is equal to negative 1/2 x squared. Now you might say, why didn't you put a plus c on the left? Because again, I am going to put it on the right and I could bring that over and there would be some constant. So you don't have to put it on both sides. You just put it on the right. But make sure you understand that you have to put this constant of integration right after you integrate. It cannot come on another line. It has to be right there. After we do that, we use our initial condition. So if I plug in, there's only one exception to this rule, and we'll talk about that later when I don't substitute in first. So I have negative 3 squared is equal to negative 1/2 plus c. So what do I got? What is that? 9/2 is equal to negative 2 plus c. So c is going to be, if I add 4 over 2, 13/2. Now remember, what's my answer? That's not my answer. Friends, I go back up to this line right here. So I plug that number in right. See how I just recopied that? I'm going to put my c in right in this same line. My last step is I need to solve for y. So if I give this to an Algebra 2 kid and said, hey, get that to say y equals, the first thing they're probably going to do is multiply by 2. So I'd get rid of all those denominators. I'd have that. And then what would you say after that? Well, I'd take the square root. So I don't know why I'm writing it that way, but I like it better. But when you take the square root, remember you have to put the plus or minus. But here's the problem. Remember, this is called the general solution. The general solution, there's thousands of answers that have this derivative. When they give you an initial condition, then how many equations should you have? You should have one. If you put that plus or minus, how many do you have? You have 2. So you've got to figure out this point is only on one of those. So let's plug in. You literally have to pick the plus or minus. Do you see that if I put 2 in for x, okay, that'd be the square root of 9, which is 3. What am I supposed to be getting out? I'm supposed to be getting out -3. So I have to pick the negative. So the point negative or 2, -3 is only on the negative square root. That's why for my final answer, I have to put y equals negative square root of 13 minus x squared. This is the solution, the particular solution to my differential equation. I literally have to pick. Okay? Now let's look at number 2. Let's read that one. Given that y equals f of x is the particular solution of the differential equation, write the equation of the tangent line to f of x at the point 2, -8. Well, what's funny, and I threw this one in here because people see the word particular solution and they go, oh, I'm solving for the particular solution. And you're like, wait a minute, you just told me that this was a non-separable one, and in our class we'd only be doing separable ones. So how am I supposed to do it? You're not reading the question carefully. Even though it says the word particular solution, what does this question ask you? Write the equation of the tangent line to f of x. F of x is the particular solution. If you solve that for y, okay, because you can with non-separable, it's just something that we don't do. F of x is that particular solution. What do we need for the equation of a tangent line? You need a point and you need a slope. Do you know the point that it goes through? Yeah, you have this one right here, 2, -8. What else do you need? You would need the slope. So the slope, and again, I'm going to evaluate, so I need to have this notation. The slope is going to be given by that. Isn't that what dy dx is? So if I plug -8 over 2 plus 1, what is that, -3? So the equation of the tangent line is y plus 8 is equal to -3 x minus 2. You can do that problem. Just because you see that word, it didn't say find the particular solution. It said write the equation of the tangent line. You do not need the equation of y to write the equation of the tangent line if they give you the point. So I just wanted to throw that in there because what people do is they start trying to solve this and they never can do it because we don't do those, and they waste a whole lot of time. So be very careful what the question is asking you. Okay, now solve. Yeah, when I say solve, that means find the particular solution. So again, when you're solving a differential equation, let's talk about our steps. Let's separate. So dy, I would have 2y cubed is equal to x minus 3 dx. So that's step 1. It's always to separate. My next step is to integrate. And if I integrate, I'd have 1/2 y to the 4th is equal to 1/2 x squared minus 3x plus c. Then what do? I put in my initial condition. So that means if I put in, this is my x, if I put in 6 for x, I should get out -2 for y. So that's 16, that's 8, that's 36 divided by 2 is 18 minus 18 plus c. So c is equal to 8. So where do I go back? I go back right here into that line. And instead of writing plus c, I write plus 8. But what's my last step? My last step is to solve for y. So again, I'm going to multiply by 2. So I have x squared minus 6x plus 16. I'm going to take the 4th root Again, when you're taking fourth roots, it's just like the square root. You have to pick plus or minus. So technically I get a plus or minus there. But again, if you think about a square root or a fourth root, you're always going to get a positive. So 6 negative 2 lies on the negative square root. So my final answer is this. Do you put plus and minus if you're doing a cube root? No. So don't do that if you are doing a cube root. And again, a lot of people say, Ms. Root, what if right here I like multiplied by 2 first and I would get a different constant? Listen, you can solve for your constant any point, but the deal is you have to plug in back where you plugged in your initial condition. That's the C that you're solving for. So I just do it right after I plug in. Once I integrate, I go right there and I just deal with the numbers. All right, let's do this last one. This one has a little different look to it. Okay, so that looks interesting. Well, first of all, let's see what our answer should look like. Remember, what I really have is dp dt minus t squared. I have dp dt. So remember, what is my answer going to look like? I'm going to have an equation for p, the top one, in terms of t. So in other words, I need p equals, and then all this stuff over here needs to have t's in it. That's what I'm looking for. So let's separate the variables. A lot of times people mess up with that separating. Okay, so dp dt, let's write this a little different way. I could write that as 1 over p squared. Let's move that t squared to the other side. So I'd have t squared. Now what? Well, let's multiply through by dt. So then I would have it. I am going to integrate, so instead of writing 1 over p squared, it might be easier for me to write p to the negative 2, and there's my separating. So now I've got it separated. Let's integrate and integrate. So increase the power by 1, so that's p to the negative 1, divide by the new power, is equal to 1/3 t cubed plus c. I've got to put that there. And if you're following what I've said, you're going to plug in 0 for t, and you will get out 4 for y. So what is that equal to? And so I have negative 1/4. So my C is negative 1/4. So where do I plug that in? I go right back to this line right here. I have negative p to the negative 1 is equal to 1/3 t cubed minus 1/4. Now solve for p. Okay, well, let's get rid of that negative first. I'm going to do 2 steps in one. So if I got rid of that negative, it would change the sign of what's on the right side. So I could write it like this. And instead of writing p to the negative 1, wouldn't that be 1 over p? Now be careful here. So you could write this 2 different ways. I'll tell you the way that I assume it will be on multiple choice. If you flip this, I can't just flip this automatically because I don't have a common denominator. It would be p equals 1 over all that junk. I mean, that would be flipping it. Now, what would that be equal to? Because my guess is they don't like having a complex or compound fraction. Look at the denominators. Do you see that I have a 4 and a 3? If I multiply by 12 on top and bottom, what would that be equal to? Well, if I multiply by 12, on top it'd be 12. If I distribute this 12 times 1/4 would be 3. 12 times the 1/3 would be 4. And this is a prettier version of that compound fraction. So you have to do some algebra. You have to, every time you're going to separate the variables, do your integration, solve for C, and then solve for the variable you need. So practice that. All right, see ya.